What if I told you that right now, trillions of ghostly particles are sliding through your body, silent, invisible, and almost impossible to catch? They don't stop, they don't knock, they don't even notice you. These are neutrinos, the universe's ultimate introverts. Every second, they stream through your skin, your bones, even the earth itself, and you don't feel a thing. Close your eyes and let that sink in. While you're busy with bills, emails, or wondering if you forgot to lock the door, a quiet river of these ghost particles flows through you as if you weren't even here. It's strange, a little unsettling, but also kind of peaceful. You probably never thought of it this way before, and you probably don't need to wrestle with the full weight of that realization tonight. Just let the idea drift through you as softly as the particles themselves. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And there's also something new, the hype button. A single press helps push these sleepy ideas further into the algorithm, carrying them toward other curious minds who might need them tonight. I'm really curious where you're watching from. Write me in the comments what city you're in and what time it is there. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Neutrinos are so elusive that physicists once thought they were massless. Turns out they're not completely weightless, just insultingly close. Each one is lighter than the tiniest known particle, with mass, yet collectively they outweigh all the visible stars combined. Imagine dust so fine you can't see it, but pile up enough and it outweighs the mountains. That's neutrinos, a cosmic prank in the form of physics. To detect them, scientists build massive underground observatories. Picture an Olympic swimming pool dug into a mountain, filled not with chlorine but with ultra-pure water. Surround it with light sensors so sensitive they can detect a single faint blue flash caused by a neutrino finally colliding with a molecule. That's how rare the interaction is. A particle older than your grandparents' grandparents travels from the sun, maybe even a distant supernova, crosses the entire Earth without slowing down, and just once in a while leaves a signature of its passing. You could say it's the ultimate ghosting. Here's a quirky twist. In 1987, a supernova exploded in the Large Magellanic Cloud, a dwarf galaxy near ours. Before telescopes saw the light, neutrino detectors caught a whisper of particles, about 24 of them. Just 24 tiny signatures out of trillions per second, but enough to confirm the explosion before any telescope could point. Imagine betting your life savings on hearing a pin drop in a hurricane, and somehow you win. Scientists still argue whether neutrinos hold the key to why matter exists at all. Here's the puzzle. After the Big Bang, there should have been equal amounts of matter and antimatter, which should have annihilated each other, leaving only light. Yet clearly, here you are, cozy in bed. Neutrinos might carry a hidden asymmetry, a slight favoritism for matter over antimatter, that tipped the balance in favor of stars, planets, and eventually you stressing about laundry. Now for the fringe rumor. Some researchers suspect neutrinos could be portals to physics beyond the standard model, our reigning, but incomplete, set of cosmic rules. There's even speculation of sterile neutrinos, a ghost of a ghost, interacting with literally nothing except gravity. Think of it like finding out your imaginary friend has an imaginary friend. If proven, they might explain dark matter itself, or they might just fizzle into the "we thought so but nope" bin of science history. For you, though, the effect is subtler. As you breathe in the quiet night, neutrinos pass through your pillow, your bones, the earth beneath your floorboards, and emerge unchanged, as if nothing existed at all. The universe whispers constantly, but you need machines the size of cathedrals to even hear a syllable. And yet, here you are, listening. Isn't it almost comical that you, a warm lump of stardust, can be aware of something so delicate the cosmos itself hardly notices? So you drift deeper. The particles stream by without pause, and you let the thoughts slide over you like soft static. You don't need to chase them. They'll still be here long after you've surrendered to sleep. That's the irony. Neutrinos are eternal marathoners, while you're just trying to make it through Tuesday. Somewhere in that contrast, there's comfort. Turn down the lights in your mind and imagine a scale so cosmic, it stretches from the faintest star to the heaviest black hole. Now somewhere in that grand spread, there should be objects sitting between those two extremes, except, oddly, there aren't. This is the stellar mass gap, a weird desert of possibilities where nature seems to skip a step, like a cosmic bakery that sells tiny muffins and massive cakes, but somehow no medium-sized cupcakes. And no, you can't order them off menu. Here's the mainstream fact. Neutron stars, the collapsed cores of massive stars, usually top out at around 2.2 times the mass of our sun. Black holes, meanwhile, are usually heavier, starting somewhere above 5 solar masses. That leaves a blank region, a gap, between 2.5 and 5 suns where almost no known objects exist. It's as if the universe decided that being average in this mass range was embarrassing. Now picture yourself drifting across this gap like you're walking across a desert at night. The stars above don't care, but the sand feels oddly smooth beneath your feet. You glance around, expecting to see footprints, some evidence of celestial objects filling this zone. But it's empty. Nature, it seems, just leaps from super dense dead star straight to all-devouring abyss. Scientists still argue whether this is a genuine feature of stellar evolution or just a trick of incomplete data. Here's the quirky bit. Gravitational wave detectors, those laser interferometers that can sense ripples in space-time smaller than a proton, have started hinting at possible candidates inside this gap. Imagine two massive objects colliding light years away, shaking the fabric of reality, and your planet, without consent, wiggles by less than the width of an atom. Among those faint quivers, astronomers spotted mergers that suggest one object weighed about 2.6 suns. Not quite a neutron star, not quite a black hole. Like catching sight of a mythical creature, only to have your telescope battery die. And here's the cheeky part. If you were a betting person, you'd assume the universe should naturally make objects in this range all the time. Stars come in all sizes, so why not their corpses? It's like expecting a buffet to have soup, only to be told, no, sorry, we leap from salad straight to lasagna. The fringe idea? Some whisper that exotic states of matter, like quark stars, might inhabit this range. Imagine matter so dense that even neutrons break down into quarks, creating an object more compact than a neutron star, but not quite a black hole. Think of it as cosmic mystery meat. Nobody's ordered it yet, but the menu suggests it could exist. Whether that's real or just physics daydreaming remains very much up for debate. As you let this thought settle, your breathing slows. You imagine lying at the edge of a black hole's event horizon, peering down into the abyss, and then rolling back just enough to glimpse a neutron star's crust. Between them, an emptiness. Not physical emptiness, but conceptual. a no man's land where your mind tries to place something that simply refuses to show up. The universe, in its playful cruelty, sometimes prefers gaps to answers. And maybe that's why you feel the tug of sleep here. The cosmic desert between extremes mirrors your own drifting state. Not fully awake, not yet fully asleep. A twilight zone of the mind, perfectly tuned to this enigma. You laugh softly at yourself. How did you end up comparing your nap schedule to dead stars? But that's the beauty. In the quiet, you find parallels everywhere. So you let go, picturing the gravitational waves rolling past like soft ripples in a pond. Somewhere out there, colossal bodies are colliding, sending whispers across space-time just so you can tuck in and wonder about cupcakes the size of suns. You don't need the answer tonight. You just need the mystery. And in that surrender, you glimpse a strange comfort. The idea that the cosmos is unfinished. That it still holds secrets between its chapters. Perhaps the stellar mass gap isn't a flaw at all, but a deliberate pause, like the silence between notes in a song. That silence gives the music shape. That emptiness gives the story weight. Without the gap, there would be no wonder, only catalogues. And really, which would you rather dream of? Maybe the unanswered questions are the universe's lullabies, humming softly as you drift, reminding you that not everything must be solved to be beautiful. And as you hover in that twilight thought, you realize the gap is less a void and more a mirror, reflecting your own curiosity back at you. Imagine standing on a hilltop at night, gazing at the Milky Way stretched across the sky like a glowing river. You know there are hundreds of billions of stars in that haze. But if our computer models are right, there should also be hundreds of tiny companion galaxies buzzing around us like cosmic fireflies. Yet, when astronomers look, they find far fewer. It's called the missing satellites problem, a galactic version of ordering a family-sized popcorn and receiving a lonely handful of kernels at the bottom of the bucket. Here's the mainstream fact. Simulations of dark matter halos predict that the Milky Way should be surrounded by hundreds, maybe thousands, of dwarf galaxies. These dwarfs are small, faint collections of stars, but they're expected to cluster like bees around a hive. Yet so far, we've discovered only a few dozen. It's not just a small mismatch. It's like expecting a concert crowd and finding a couple of people awkwardly clapping in the front row. Now let your imagination drift further. You float above the galaxy, peering down like an owl scanning a dark meadow. You look for faint glimmers of dwarf galaxies orbiting the Milky Way, but instead of a buzzing swarm, you spot just a sparse handful. Where are the others? Are they hiding, too faint to notice? Or is the theory itself flawed? Scientists still argue whether our dark matter models are incomplete, or whether we simply haven't looked hard enough with sensitive telescopes. Here's a quirky tidbit. Some of the known dwarfs are almost absurdly fragile. The Sagittarius dwarf galaxy, for example, is being ripped apart by the Milky Way's gravity, leaving streams of stars that wrap around us like ghostly ribbons. It's like watching a marshmallow slowly melt into hot cocoa, tragic but oddly beautiful. These stellar shreds suggest we might have had more companions in the past, only for them to be torn apart and blended into our galactic disk. And of course, there's the fringe idea. What if many of the missing satellites are made almost entirely of dark matter, with so few stars that they're invisible to us? Ghost galaxies, orbiting quietly, bending space with their gravity but refusing to shine. Think of it as a cosmic neighborhood, where most houses are invisible, but you only notice them when the mailboxes tug faintly on your car as you drive by. If such shadow galaxies exist, they could solve the mystery neatly. But so far, they're just theoretical whispers. You might chuckle here. Humans worry about losing socks in the laundry, but the universe casually loses entire galaxies. Somewhere, cosmic accountants must be tearing their hair out. Yet for you, lying back in the quiet, the mystery doesn't feel like a loss. It feels like abundance. There's more out there, hidden, waiting. The missing satellites aren't gone. They're tucked away like secrets, encouraging your imagination to fill the dark. As you breathe slowly, picture those unseen companions circling our galaxy in silence. Some may glow faintly, barely distinguishable from background stars. Others may be shadows entirely, detectable only when they tug at the motions of brighter neighbors. You drift with them, orbiting in the darkness, wrapped in gravity's invisible leash. The Milky Way is not alone, and neither are you. The satellites may be missing, but the mystery is here, cradling you softly as you sink deeper into stillness. And maybe that's the lesson. The gaps in our observations aren't failures, but invitations. Each absent galaxy is a blank page, a place where theory stretches and imagination paints possibilities. Perhaps future telescopes will reveal them, faint smudges blooming like fireflies on the cosmic lawn. Or perhaps they will remain elusive, whispers that forever tease. Either way, the sky feels larger, richer, when you realize its stories aren't finished. And in that realization, you smile at the strangeness of it all, that the universe, with its billions of stars and uncountable worlds, still chooses to play hide and seek. You close your eyes and feel the pull of sleep, and in that drifting space, every missing galaxy becomes a lantern waiting to be lit, shimmering patiently in the dark, reminding you that absence itself can be luminous, and the more you think about it, the more comforting it becomes. The night sky is not a finished puzzle, but one with missing pieces, and those absences are what keep the game alive. After all, a mystery solved is a story ended. A mystery unsolved is a lullaby that never stops singing. Picture yourself slipping into the early universe just minutes after the Big Bang, when everything was a roiling soup of particles. In that fiery kitchen, the cosmos baked up the first ingredients: hydrogen, helium, and a sprinkle of lithium, like a chef garnishing a cosmic cocktail. And yet, billions of years later, when astronomers measure the lithium in ancient stars, it doesn't add up. There should be 3 times more of it. This mismatch is called the cosmic lithium problem. Basically, the universe misplaced some seasoning, and we still can't find the shaker. Here's the mainstream fact. Big Bang nucleosynthesis, the theory that explains how the first light elements formed, makes very precise predictions about how much lithium should exist. Hydrogen? Checks out. Helium? Perfect match. Lithium? Not even close. The predictions say there should be about 3 times as much lithium as we see in old metal-poor stars. Imagine baking a cake, pulling it from the oven, and realizing the sugar is mysteriously missing. Except instead of dessert, it's the entire cosmos. Now let your mind wander into those ancient stars, one so old they glow faintly red like embers in a fire that never went out. These stars should be fossil records of the universe's first chemistry. But when scientists measure them, they keep coming up short on lithium. Some argue the stars burned it away over billions of years. Others think the recipe from the Big Bang was wrong from the start. Here's the quirky detail. Lithium is fragile. Unlike heavier elements, it can be easily destroyed in stellar interiors. So some astronomers propose that stars may slowly eat their lithium, pulling it into hotter zones where it's destroyed. It's like leaving cookies unattended near a group of teenagers. You don't need to wonder where they went. But the math doesn't quite add up. Not all the lithium could have been eaten this way. And then comes the fringe speculation. Maybe new physics is hiding in the background. Some theories suggest exotic particles, like decaying dark matter or heavy neutrinos, might have interfered with lithium production in the early universe. It's a bold idea, like blaming missing socks not on the dryer, but on mischievous interdimensional thieves. No evidence yet, but it keeps the cosmic conversation lively. As you breathe deeper, you imagine the missing lithium scattered like glitter across space, just faint enough that no telescope can catch it. Maybe it's tucked into invisible stellar layers, or maybe it never existed in the first place. Either way, the absence leaves a quiet hum of curiosity, the kind that lulls you toward rest. You picture scientists as stargazing detectives, notebooks in hand, chasing a culprit that may never be caught, yet thrilled by the chase itself. In a way, the mystery is its own kind of discovery, proof that the universe still knows how to keep secrets. And isn't that what draws us in? The thought that not every lock has a key, not every riddle a neat solution. You let yourself drift into the metaphor. You are the star, carrying traces of ancient ingredients within. Some of them glow clearly, like hydrogen in your blood and calcium in your bones. Others, like lithium, are barely detectable, whispers lost in the depths. Just as the stars hide their secrets, so do you. And somehow, that feels comforting. The gaps don't make you less whole. They make you more mysterious. A constellation drawn with missing lines. So you roll softly in your bed, smiling at the absurdity. The universe can calculate the age of galaxies and the size of the observable cosmos, but it still can't balance its lithium checkbook. If the cosmos itself can have loose ends, maybe it's okay if your to-do list does too. Imagine the cosmos as a distracted chef, spilling lithium under the counter, shrugging, and serving the dish anyway. Life went on, galaxies formed, planets coalesced, and here you are, puzzling over the seasoning billions of years later. You close your eyes and let the thought sink in. Your heartbeat, steady and quiet, is powered by processes shaped in that same early universe. The hydrogen in your veins, the oxygen in your breath, the calcium in your teeth, all born of cosmic furnaces. And somewhere in that grand lineage, a missing sprinkle of lithium remains unaccounted for, like a riddle written into your bones. The stars may never reveal it, but you carry the question anyway. That missing note becomes a lullaby, humming softly in the background, reminding you that imperfection is not a flaw, but an opening, an unfinished melody you get to carry forward. Imagine a star dying in a blaze so violent that what's left behind is compressed tighter than anything you can imagine. Not a black hole, but something stranger. A neutron star with a magnetic field so ferocious it could wipe every credit card on Earth if it were parked halfway to the moon. These are magnetars, the universe's extreme drama queens. They don't just sit quietly in the night sky. They hiss, snap, and occasionally fling out bursts of radiation that make our sun's tantrums look like candlelight. Here's the mainstream fact. Magnetars are neutron stars with magnetic fields up to 1,000 times stronger than typical neutron stars, reaching 10 to the 15th Gauss. For perspective, Earth's field, the one that politely nudges your compass, is about half a Gauss. The difference is so absurd, it's like comparing a handheld fan to a Category 5 hurricane made of pure magnetism. Now let yourself drift closer, but not too close, because your atoms would rearrange themselves like paper clips near an industrial magnet. Picture lying on a cosmic beach as this monstrous star spins slowly, dragging its magnetic field through space like invisible tides. Every so often, it cracks, literally. The crust of the star shifts under the strain, sending out a starquake that can release more energy in a second than our sun does in 100,000 years. And you thought your upstairs neighbor stomping around at 2 a.m. was loud. Here's a quirky tidbit. In 1979, detectors on Earth caught a sudden, intense blast of gamma rays from a magnetar in the Large Magellanic Cloud. For a fraction of a second, the energy output rivaled the brightness of the entire galaxy. The detectors went off so hard, at first scientists thought it was nuclear war. Imagine being in the control room, alarms blaring, only to realize it's just the cosmos throwing a magnetic tantrum. Scientists still argue whether these insane fields come purely from the way the star collapses, or whether some exotic mechanism, like superconducting currents in the dense interior, helps sustain them. The models are incomplete, the math gets messy, and magnetars don't exactly answer questionnaires. And then there's the fringe idea. Magnetars might be connected to fast radio bursts, those mysterious millisecond-long signals we occasionally pick up from deep space. Some researchers think magnetars snapping and flaring could explain at least some of those cosmic pings. If true, then every time you read a headline about a mysterious alien signal, there's a decent chance it was just a magnetar slamming its fist on the cosmic table. But the story doesn't stop there. Magnetars may also forge heavy elements in their cataclysmic flares, seeding the cosmos with gold and platinum. Think about that. The wedding ring on your finger, the circuitry in your phone, may owe its existence to a starquake in some long-forgotten corner of the galaxy. Extreme tantrums become gifts, scattering treasures across time. Suddenly, the drama queen feels more like a cosmic artisan, sculpting the periodic table one outburst at a time. Other times, magnetars behave like haunted houses. Their fields twist space-time itself, and photons leaving their surfaces can be polarized, warped, bent into strange orientations. Astronomers squint at these signals, trying to decode the fingerprints of magnetism etched into the light. It's like listening for ghost stories in the static of a broken radio, half frightening, half fascinating. You breathe in and out slowly, picturing the calm aftermath of a storm. Magnetars may rage, but they also whisper, spinning down over thousands of years until their fields weaken. By then, they're just tired neutron stars, quiet relics of once violent lives. In a way, they're like you at the end of a long day, still magnetic, but mostly out of energy. As you sink deeper into relaxation, the image of these stellar oddballs hovers in your mind, burning bright, collapsing, cracking, then calming. The night sky above you feels alive with their hidden presence, as if the universe occasionally winks with a magnetic flash, reminding you that even stars have tempers. And just like that, you let the thought go, floating into the quiet. And if you dream of storms tonight, maybe you'll also dream of their aftermath, of rare metals born in fire, of strange pulses traveling through the void, of the peculiar beauty that comes when even the universe loses its patience for a moment and then sighs itself back into stillness. You smile, realizing that even cosmic tempests eventually cool, leaving behind stories written in starlight. And in that soft recognition, you too feel quieter, as if the magnetar's long exhale has brushed against your own, reminding you that rest is part of the cycle. Let your thoughts loosen like threads of smoke as you picture something so small, so delicate, it slips between the cracks of every experiment we've built. This is the action. A hypothetical particle so light it makes a feather look heavy, so shy it's never shown up to a lab test. Yet if it exists, it could make up the mysterious dark matter that outweighs all the stars, planets, and glowing gas combined. You drift with the idea. The universe may be mostly made of invisible whispers, and we don't even know if they're real. Here's the mainstream fact. Dark matter is estimated to account for about 85% of all matter in the universe. We know it's there because galaxies rotate too fast for visible matter alone to hold them together. Something unseen provides the extra gravity. Axions were proposed in the late 1970s to fix a problem in particle physics called the strong CP violation, but they quickly became a leading dark matter candidate. A 2-for-1 deal. Solve one mystery, maybe explain another. Now imagine lying under a night sky, aware that if actions exist, they're flowing through you constantly like a cosmic breeze. They wouldn't collide, spark, or glow. They just slip past unnoticed. If regular matter is the noisy party guest spilling drinks, axions are the silent introvert hovering by the snack table, practically invisible. And yet, their sheer numbers could sculpt the architecture of the universe itself. Here's the quirky part. One proposed way to detect axions involves gigantic detectors with powerful magnetic fields designed to coax axions into transforming into photons, tiny flashes of light. It's like trying to catch an introvert by inviting them to karaoke night and hoping they'll sing. So far, the stage remains quiet, but experiments like ADMX in Washington are still listening for that cosmic whisper. Scientists still argue whether axions are the answer to dark matter at all. Maybe dark matter is made of something else entirely. Weakly interacting massive particles, WIMPs, sterile neutrinos, or something no one has dreamed up yet. It's the scientific equivalent of rummaging through a junk drawer and insisting, "I know the batteries are in here somewhere." And then the fringe theory. Some physicists speculate that axions might form bizarre structures called axion stars, clumps of pure dark matter that glow faintly by converting into photons at their edges. Imagine entire celestial bodies made of invisible substance, drifting like ghosts through space, occasionally shining in wavelengths our telescopes could detect. It sounds wild, but then again, so does most of modern cosmology. Other proposals get even stranger. Axions might subtly alter the cooling of white dwarfs, or ripple through neutron stars, leaving fingerprints we haven't yet recognized. It's as if the universe left clues everywhere, but scribbled them in handwriting so faint we're still squinting. Each observation, every wobble, every unexplained signal is a potential breadcrumb in the dark. The puzzle isn't just about particles. It's about learning how to read the cosmos when half the letters are invisible. You breathe slowly, letting the thought soften. If actions exist, they might be all around you right now, brushing through your pillow, your skin, your bones, with no resistance. You wouldn't feel a thing, yet their presence could be the reason galaxies cling together instead of flying apart. You are, in some sense, wrapped in their invisible embrace, cradled by particles that might not even exist. And in that embrace, you sense an odd comfort. The universe is built not only from what is visible, but from what hides, shy and unmeasured. And maybe that's the most calming part. The universe holds secrets so quiet, they may never reveal themselves fully. You don't need to solve them tonight. Just imagine the gentle flow, the cosmic breeze, carrying you further into rest. The actions, real or not, become lullabies of possibility, proof that silence itself can shape the world. Somewhere, detectors hum, waiting for a whisper. Somewhere, galaxies swirl, trusting in the unseen. And here you are, closing your eyes, letting the dark matter of mystery rock you towards sleep. And as you drift, you realize the best puzzles aren't solved quickly. They linger, shimmering just out of reach, like fireflies in tall grass, guiding you not to answers but to wonder. The stars overhead no longer feel like distant pinpricks, but companions keeping vigil, as if they too are waiting for the shy particles to finally step forward and introduce themselves. And if they never do, that's fine. The waiting itself becomes a story, a reminder that some beauty lies not in what is found, but in what remains hidden, inviting us to dream. Imagine stretching out under the night sky, staring at the faint red glow of distant galaxies. Astronomers say that red tint means those galaxies are racing away, carried by the expansion of the universe itself. But not everyone has always agreed. Some once wondered, what if light itself just gets tired? What if photons, after crossing billions of light years, lose energy the way you lose enthusiasm halfway through laundry? This alternative is called the tired light hypothesis. Here's the mainstream fact. The redshift we see in galaxies is one of the strongest pillars supporting the idea of an expanding universe. Edwin Hubble's famous discovery in the 1920s showed that galaxies are receding from us, with more distant ones moving faster. It's the ultimate traffic jam, except the lanes of space itself are stretching apart. Yet the tired light idea lingers like an old rumor at the edge of the party. Now picture it. A single photon leaves a galaxy when dinosaurs still walked the Earth. It races across cosmic time, never slowing, but perhaps, just perhaps, dropping a little energy along the way, turning redder, fainter, wearier. If true, it would mean the universe isn't expanding at all. Instead, light itself carries the burden of time, arriving to us like a marathon runner collapsing at the finish line. Here's the quirky bit. If tired light were real, images of distant galaxies would look smeared, blurred by the energy drain. But when we peer through our best telescopes, we see galaxies crisp and clear, no more fuzzy than physics allows. It's as if the photon ran the marathon and showed up with perfect hair and eyeliner intact. That's one reason mainstream science doesn't buy the theory. Scientists still argue whether there's any room left for tired light, especially as new tensions arise in our measurements of cosmic expansion. The so-called Hubble tension makes people revisit old possibilities, if only to poke them for overlooked hints. But the consensus remains. The universe is stretching, and photons aren't simply nodding off on the job. And then comes the fringe flavor. Some imaginative versions suggest photons might interact with hidden particles or subtle fields that drain them without leaving a trace. It's like a cosmic toll booth where the toll collectors are invisible and the receipts evaporate. Convenient, but hard to prove. Others even speculate about quantum effects slowly bleeding energy from light. But those ideas sit more in the realm of daydream than evidence. And crucially, tired light has a bigger problem. It can't explain the cosmic microwave background, that faint afterglow of the Big Bang. Expansion predicts it beautifully. Tired light stumbles, leaving the universe strangely inconsistent. Still, the image has charm. A photon trudging across eons, its color fading like a well-loved photograph, appeals to something human. We understand exhaustion. We know the feeling of journeys that leave us pale but intact. And maybe that's why the hypothesis survives in imagination, even when it falters in data. It feels like a story written for tired people in a tired age. As you let that image linger, you breathe more slowly. You picture the photons arriving at your eyes from distant stars tonight. Bright, crisp, still carrying their full story. Each one has traveled unimaginable distances without tiring. If they can make the trip, maybe you can make it to morning. The tired light idea may not hold up scientifically, but as a metaphor, it fits perfectly. Sometimes you feel drained, but the core of you keeps shining. Now imagine that your thoughts are photons too, darting across the expanse of your day. Some of them may fade at the edges, growing softer, dimmer, but they still carry their essence to the finish line. The glow in you isn't undone by fatigue. It's just stretched, redshifted, turned into a calmer kind of light. In that sense, tired light is real after all, not in the physics, but in the poetry. You smile softly at the thought. If the universe can keep its photons lively for billions of years, maybe it's okay if you yawn after a long day. The light doesn't mind, and neither should you. Every photon tells you the same quiet truth. Endurance doesn't have to look loud or sharp. Sometimes it's enough simply to arrive, carrying your story across the dark, shining just enough to be seen. And if you feel yourself dimming, don't mistake it for disappearance. Even the reddest glow carries meaning, proof that you've traveled, endured, and left behind a trace of light no darkness can erase. And in that reassurance, you find calm. Your glow, however faint, is still part of the universe's endless story. Drift into the deep night and picture quasars. Those blazing hearts of young galaxies, powered by black holes devouring matter at ferocious speeds. Each quasar spins like a cosmic lighthouse, its jets beaming energy across billions of light years. You'd expect their orientations to be random, like scattered leaves on a pond. But here's the odd part. Across regions of space too vast for comfort, many quasars seem to align, their spins pointing in eerily similar directions. It's as if the universe hired a cosmic choreographer to arrange its dancers. Here's the mainstream fact. Quasars are among the brightest objects in the universe, shining with the light of trillions of stars. Their jets, spewing from near light-speed disks of matter, should be randomly oriented across the sky. Yet observations reveal clusters of quasars with axes mysteriously lined up, stretching across billions of light years. Imagine tossing a handful of straws onto the ground, only to find they've landed parallel in neat rows. Now, picture yourself floating through these vast cosmic structures, the quasars spinning in slow harmony like distant ceiling fans in a cathedral of stars. You shouldn't see patterns on such scales. Physics says causality can't link objects separated by billions of light years. Scientists still argue whether this alignment is a real physical effect, or some statistical fluke amplified by the limits of our data. Here's the quirky tidbit. One study suggested that quasar alignments might trace the filaments of the cosmic web, the grand scaffolding of dark matter that stretches across the universe. If true, the quasars are like glowing beads strung along invisible threads, each bead twirling in rhythm with its strand. It's less random chaos and more galactic embroidery. And then there's the fringe idea. Some have whispered about exotic physics, perhaps the influence of primordial fields left over from the Big Bang, or even hints that the universe itself may have a preferred direction. A cosmic arrow hidden in plain sight. It's a provocative thought, like realizing your supposedly infinite quilt of stars has a seam running through it. Other possibilities stretch the imagination further. What if these alignments hint at topology on a cosmic scale, suggesting the universe might not be truly infinite, but wrapped, curved, folded in ways we can barely picture? A hall of mirrors so large that quasars echo each other's orientations across unfathomable distances. To glimpse such order would mean brushing against the architecture of reality itself. And there are whispers of something subtler, that perhaps the quasars are tracing patterns of polarization left behind by gravitational waves rolling through space-time, ancient ripples from the very birth of the cosmos. If so, their alignment wouldn't just map matter, but history itself, a frozen record of the universe's first trembling breaths. To look at them would be to read a diary written in jets of light, stretching across billions of years. As you breathe, you let the image soften. Jets of energy stretching outward, faintly aligned, weaving subtle patterns in the night. You drift between them, weightless, letting their quiet harmony steady your own restless thoughts. Whether it's coincidence, cosmic web geometry, or something stranger, the effect is the same. You feel lulled by order in a place you expected only chaos. The quasars become less like engines of violence and more like instruments in a distant orchestra, playing notes so low and long you can only feel them in your bones. Their song is patient, stretching across eons, humming with a unity science has yet to pass. And perhaps that's the lesson tonight. Even when the universe looks like random scatter, sometimes patterns emerge, guiding your gaze and your thoughts towards stillness. You don't need to know why. You just float with the quasars. Their spins like lullabies sung in unison across eternity. Their alignment may puzzle astronomers, may spark arguments in papers and conferences. But for you, lying beneath the stars, it carries a simpler message, that somewhere in the immensity, chaos hums with a hidden rhythm. And in that rhythm, you find rest. You close your eyes, and the quasars continue to whirl, distant but aligned, guardians of a secret you don't need to solve to feel its peace. And as you drift towards sleep, the thought lingers gently. Even across unimaginable distances, harmony can emerge, and so perhaps it can within you too. If the quasars can find order across billions of light years, maybe your scattered thoughts tonight can find it as well, weaving themselves into a quiet constellation of calm. Let your awareness drift towards sudden flashes in the night, explosions so powerful they outshine entire galaxies, yet vanish within seconds. These are gamma-ray bursts, or GRBS, and they are the universe's equivalent of a cosmic camera flash. Brilliant, disorienting, and gone before you can blink. If you are unlucky enough to be nearby when one went off, you wouldn't even have time to think, uh-oh. Thankfully, the odds are on your side. Tonight, you only need to marvel at the mystery. Here's the mainstream fact. Gamma-ray bursts are divided into two main types. Long-duration bursts, lasting more than 2 seconds, are thought to come from massive stars collapsing into black holes. Short bursts, less than 2 seconds, likely result from neutron star mergers. Both mechanisms unleash energy so immense that for a brief moment, they rival the combined brightness of all stars in a galaxy. Imagine striking a single match and having it outshine Times Square for a heartbeat. Now picture yourself drifting through the darkness when, suddenly, the void flickers, an otherworldly glow that flares and fades before your eyes adjust. You barely have time to register it. That's how fleeting these events are. Yet telescopes race to swivel, catching the afterglow in other wavelengths, X-rays, visible light, even radio waves. Sometimes we catch the smoking gun, other times nothing but silence. Scientists still debate whether we fully understand all the origins of GRBS, or if other exotic engines, like magnetars or primordial black holes, occasionally add to the mix. Here's the quirky part. In 1997, astronomers finally confirmed that GRBs were coming from distant galaxies, not our own backyard, by catching an optical afterglow with the Beppo-SAX satellite. Before that, people weren't even sure if these bursts were local fireworks or distant cosmic artillery. The truth turned out to be both less sci-fi and more staggering. Ordinary stars, dying extraordinary deaths. And here's the fringe speculation. Some researchers wonder whether GRBS could have influenced life on Earth. A nearby burst in the past might have stripped away parts of our atmosphere, triggering extinctions. It's an unnerving idea, but also oddly humbling. Our planet may have survived not just asteroids, but cosmic death rays from afar. Don't worry though. The nearest likely sources are safely distant. At worst, they're cosmic paparazzi, flashing their bulbs from across the universe. Other mysteries remain. Why do some bursts shine brighter than expected, or last longer, as if powered by engines we don't yet understand? Could some be relics of the earliest stars, those giant, short-lived behemoths that seeded the cosmos with heavy elements? If so, every burst might be a time machine, a flare that lets us glimpse the first chapter of cosmic history. In that sense, GRBS aren't just endings. They're invitations to look back at beginnings. Even more astonishing, short GRBs from neutron star collisions forge heavy elements like gold and platinum. Every ring, necklace, or coin on Earth may trace its ancestry to a burst of unimaginable violence. Something so fleeting, so lethal, became the source of beauty we carry in our pockets and wear on our skin. Violence and value, destruction and creation, forever entwined. As you breathe more slowly, let the bursts fade in your imagination, leaving only a soft afterglow. You picture them not as threats, but as fireworks, brief markers of endings and beginnings. A star collapses, a merger completes, and in the blink of an eye, energy floods the cosmos before dissolving back into quiet. You drift with that rhythm, flash, fade, rest. Each burst may be violent, but its afterglow lingers like a cosmic exhale, stretching out across the night for days, weeks, even years. And maybe that's the most soothing takeaway. The brightest bursts in the universe don't last. Neither do your worries. Each flare dims, leaving room for calm. Tonight, you're safe to watch them from afar, letting the afterglow settle into the stillness of your own thoughts. Like a firework seen from a quiet hill, their violence becomes your lullaby, a fleeting blaze, a fading glow, and then the comforting silence that follows. And as you close your eyes, you realize even the most overwhelming bursts pass, leaving behind not fear, but a gentle memory of light. That memory is yours to keep, your own afterglow, soft, steady, reminding you that every storm ends and every night makes space for rest. And in that thought, you find peace. You too can burn bright, fade softly, and let the universe cradle you in its calm. Now let your awareness drift even wider, beyond galaxies, beyond clusters, into the vast landscape of the cosmos itself. Imagine our Milky Way as a small boat on an endless ocean, tugged and pushed by unseen currents. Astronomers once thought we were simply being pulled toward a massive attractor, a cluster of galaxies drawing us in. But the story is stranger. Part of our motion seems to come from being pushed away by something vast and empty. This odd phenomenon is called the dipole repeller. Here's the mainstream fact. Careful mapping of galaxy motions shows that the Milky Way and its neighbors aren't just drifting randomly. Part of our motion is explained by attraction toward dense regions like the Shapley supercluster. But another part points the opposite way, as though a huge void, an immense region with fewer galaxies than average, is repelling us. Not with literal force, but with the relative push of surrounding mass. Gravity tugs everywhere else, so an underdense region feels like a shove. Picture yourself floating in that void, surrounded by silence. No bright galaxies, no clusters, just the faintest drizzle of matter. You feel the strange push of absence, like the hush that falls when someone leaves a crowded room. It's not what's there, but what isn't, that shapes the flow. Scientists still argue whether the dipole repeller is a true structure or just a mathematical artifact of how we measure galaxy velocities. Here's the quirky bit. If you could somehow sail to this cosmic void, it would be so empty that even darkness would seem louder. Galaxies are the universe's street lamps, and here the lamps are few and far between. Imagine wandering a city at night, where half the neighborhoods have no lights at all, yet somehow those dark blocks push you toward the brighter ones. And then the fringe idea. Some theorists play with the notion that cosmic voids could be windows into new physics, perhaps shaped by exotic energy fields, or even offering insights into dark energy itself. If true, emptiness might not just be lack, but presence, an actor in the drama of cosmic motion. Like discovering the silence between musical notes is actually part of the song. To make things stranger, simulations show that voids aren't truly barren. They contain wisps of dark matter and faint galaxies too dim for ordinary surveys. They're like hidden valleys on a map, unlit but not lifeless, influencing the roads around them. If the dipole repeller is real, it's not just a hole. It's a sculptor, carving the flows of galaxies across unimaginable distances. Astronomers sometimes describe these maps of motion as cosmic rivers, with galaxies drifting like boats on currents defined by both peaks and valleys. Our Milky Way is just one vessel, tugged toward clusters, steered away from voids, following paths laid down long before our sun was born. In this view, we aren't wandering aimlessly, but gliding along channels etched by gravity and absence alike. And there's a curious symmetry here. The universe needs both crowded superclusters and hollow voids to create its grand tapestry. Remove the emptiness and the structure collapses. Remove the structure and the emptiness loses its meaning. The cosmic web only exists because of both. It's the same with your own life. Your days are shaped not only by the things you choose, but also by the things you decline, the spaces you leave open, the silences you honor. As you breathe deeply, the thought of being guided by both pulls and pushes feels strangely familiar. In your own life, you're drawn toward some things, comfort, warmth, connection, and pushed away by others, stress, noise, clutter. Both forces shape your path. The dipole repeller is the universe reminding you that absence matters too. Emptiness can redirect as surely as fullness. Silence can guide as powerfully as sound. So you let the image fade, the Milky Way gliding across the fabric of space, drawn by clusters, nudged by emptiness, always in motion. Just like you tonight, drifting between wakefulness and sleep, carried by pushes and pulls you barely notice. And somewhere in that gentle flow, you find rest. The void is not frightening. It is part of the balance, part of the music of motion. Even absence has its role, and in honoring it, you surrender to the drift, letting it carry you softly into calm. You're a voyager in your own quiet current, carried through the dark towards stillness. And in that stillness, you recognize something simple and profound. Sometimes what guides you most is not what is present, but what has gracefully stepped aside. And now, let the mysteries linger only as faint echoes, fading like starlight scattered across the horizon of your thoughts. You've wandered through particles, gaps, bursts, and voids, yet here you are, safe and quiet, carried by the steady rhythm of your breath. Each unanswered question becomes a lullaby, each debate a softer hum. The universe doesn't rush to explain itself, and neither do you need to. You can let the puzzles rest, knowing they'll still be there tomorrow, patient and eternal. Tonight, only stillness matters. Let your mind drift. Let the cosmos hold you. Sleep. Sweet dreams.